All right, so one thing that I didn't say earlier is I'd really love to hear from people in the community about other blockchain events that are coming up, or if you'd like to run one like through this meetup group, or if there's a bunch of you getting together to hack on something. I think the next one that I'll organise will be a hackathon, so it'll be a very tech-only, hard tech, let's write some smart contract style thing.
Good user experience.
Good, yeah. To be announced. Yeah, so everyone's talking, which is great. There's some, I haven't really mentioned, but there's a few quite senior people in here who are hiding in amongst shadows, so I'll let you find each other. My presentation for tonight is not finished. I had to deal with a sick child last night, so I'll get through what I can without standing in front of it. In fact, I'll stand over here. And really what I was going to talk about was... Oh, no, it's all right. I'll do it. Yeah, it's cool. Thanks, Gib. What's next for mining? And I guess one of the things that really jumps out at me about this area is there's some pretty common misconceptions that I keep hearing over and over again. And I think it's just that they exist because people don't really correct them. And I'm not being pedantic or anything, but I think it's good to understand what mining is and how it plays into proof of stake, which is the thing that sort of seems to be looming on the horizon. So my name, David Novakovic. I know quite a few of you and don't know quite a few of you, so welcome to people I haven't met before. You'll know me from stuff around the place, been on the coast for a long time. So I couldn't not do this presentation and not put my Ethereum address on my first slide, so if you want to send me money, that's the place to do it. So yeah, like I was saying, some misconceptions. I think these are ones that I hear a lot. Mining is about creating currency. So if you run a miner, the thing is, I run a miner, and what it does is creates Bitcoin, or it creates Ether. That's actually simply not the case. So I thought I'd clarify that. If I'm like going too beginnerish type here, then tell me to hurry up. Because it's hard to gauge like where people are at, and this is kind of going to be a little bit technical. So another one is mining is a processing power arms race. You hear about these sort of Finnish bunkers full of ASIC miners, and that is also a misconception, although there is some truth to it, that you need special hardware to mine. Or that mining is the only way to make money from blockchain, which I guess everyone here knows is not the case.
Can you just clarify that in terms of the activity that the miner does, they do get a flow of funds to support that?
Yes.
And you do need significant compute power typically in order to lead the mining before another node. So this is where the misconception comes from. Maybe you should help us understand that.
That's exactly what I'm going to do. So the first one is that mining is creating money. Excuse me. So yes, when you do Bitcoin mining or Ethereum mining or whichever coin you choose, you do get paid for doing it. The difference, though, is that the process of creating new blocks on a blockchain is not creating money. What it is that you get paid as a reward or a transaction fee for being involved in that process. So this is significant for reasons that I'll talk about a little bit later. So it's good to understand that when you're contributing to a blockchain, the fact that you sit there and your machine's running hot or you've got a mining rig or whatever that's going crazy, you are not creating money there. What you are doing is participating in the blockchain, and that process is something that needs to be rewarded, otherwise people wouldn't do it. And this is the whole cultural thing about mining, is that it's not, digging up gold. It is about being rewarded for verifying and verifying to be true the history of the blockchain as it stands right now. And the next blocks that get added to it without consensus about whether those things are credible or not, blockchain as a concept does not work. So when you are mining, you are just being paid to make the network real. So the second one is that mining is a processing and power arms race. Now, obviously, this is true. Especially in the case of Bitcoin. I read this stat the other day that I think 70% of the hashing power in Bitcoin is coming from 4 Chinese pools at the moment. And I don't know that I can get cheaper power or cheaper hardware than the Chinese can. So, so in the case of Bitcoin, without a doubt, this is absolutely the case. But there's other coins where the whole idea of not needing special hardware and power and stuff is kind of built into the coin itself. And I'm not just talking about Ethereum or other coins that are intentionally designed to trip up ASIC miners. So yeah, I found this stat as well, which is a single Bitcoin transaction. So this isn't like mining a Bitcoin, this is doing a transaction on Bitcoin, like sending money from one person to another, requires as much electricity as a daily consumption of nearly 2 or 1.5 American households. That's a lot of power just to send money to someone, right? So there is absolutely truth to it. And check out, this presentation is online. I'll put the link in the Meetup as well as the other presentations if I'm allowed. Check out the link. There's some interesting stuff happening around sort of people realizing, well, I mean, in the community it's well known, like this stuff is not like green, right? This is not clean, what is happening at the moment. So there's certainly interesting conversations. And this article in particular that's linked here is written by an environmentalist who's interested in Bitcoin as well. New presentation software, and I've done the wrong thing. So you need special hardware to mine. If you want to go and mine Bitcoin competitively, yes. But for Ethereum, for example, this problem was acknowledged very early in the piece. In fact, it's built into the design of Ethereum that it is hard to mine with specialized mining hardware. Now, the reason that Ethereum, that Vitalik said that this is the case is because what happens is the China 4 pools, 70% of the hashing power in Bitcoin right now is centralized ownership of the creation of currency, right? So in the case of China, I don't know who's heard of the 51% problem? A few people. So I won't go into detail, but China essentially, and it's a theoretical thing right now, but if that 70% hashing power colluded, they could rewrite the history of the blockchain and invalidate everyone's Bitcoins. I don't know if those people who are running those pools know each other, but certainly if the Chinese government blocked outside pools, that would be well on their way to making that thing a reality. I've linked to the Ethereum white paper here because what Ethereum does is the processing that happens as part of the Ethereum blockchain creation and just generally in terms of smart contracts is that that is general purpose processing. You cannot build specialized hardware to run a general purpose program. It's a general purpose program. The way to make general purpose programs run faster is to build faster processors. And I think a couple of companies have been trying to do that, like Intel. So go and check out the section in the Ethereum white paper is actually quite short, but it's very descriptive about the problem that they're trying to avoid. Press the right button this time. And yeah, last one. Mining is the only way to make money on blockchains. This actually isn't the case anymore. I mean, we all know that conducting business on blockchain would be a good way of making money. That's an obvious one. But there's other ways that as a non-miner, you can contribute to a blockchain and be paid for it. I'll go into that later. That's the slide that's missing off the end of my presentation. So if I forget it, remind me to talk about it. So, getting back to mining being about creating currency. if it's not about, if you don't stand there with a, your rig kind of virtually mining coins out of something, then what is it actually doing? What it is doing is helping the network create consensus, an agreement amongst all of the nodes on the network about history, about the history leading up to the current point, or 10 seconds ago in the case of Bitcoin. What has happened that makes the reality we're in now real? And that's because as each block gets created on a blockchain, the transactions, like people sending money to each other, they are serialized into each new block that happens. So without the creation of new blocks, there's no way to be able to send money to each other, which is why in cases like Ethereum, where there's a lot of really heavy load and a lot of transactions sitting around, it can take a while for a transaction to go through because there's just simply not enough blocks being created to make that happen. And in the case of the Ethereum software, and I love Ethereum, but in the case of the Ethereum software, there's actually a pool inside the code of, it's like a queue, right? You want to send money to someone, there's a queue, the transaction goes into the queue, the miners all know, they have their own queue of transactions that are pending to be serialized. So Ethereum, if its pool of transactions on your computer, on your node gets full, it just starts like ejecting them. And not that you would lose money from that, but that transaction would not be serialized by that miner if that miner just won the next block, created the next block. Because when it creates the next block, that is where your transaction gets stored in the database of the blockchain. So, without that process of proof that the history is what it is, and these are where the ledgers sit, and who owns what, then blockchain is completely meaningless. And the reason that we need to incentivize miners to contribute to this network is about this consensus, right? And the only way, well, the best way to incentivize people is to pay them. So that is why you get paid for mining. So it's not really mining at all. But, mining's easier to say than you're contributing to the consensus of a digital currency. So, and I've stupidly completely skipped over this slide. That was what I was just saying. So, so then if you're being rewarded for creating new blocks, or at least trying to create new blocks on the network, then the coins that you get given are basically like transaction fees, right? Actually, transaction fees also exist, and they aren't the stuff that you get rewarded for mining. So mining really is a reward. It's a prize for contributing to the process. Blockchains, so Bitcoin, Ethereum, if you want to send money to someone, if you want to create a transaction on the blockchain, there is a fee associated with doing that. When a miner is sitting there receiving your potential transactions and deciding, if I get to create the next block and I'm going to put these, serialize these transactions in it, which transactions do you think they're going to choose to put into that block?
One of the most gas.
The ones with the highest transaction fees. So, transaction fees are very different to mining. Mining is about, what you get paid for mining is a reward, it's a prize. Transaction fees are a critical part of ensuring that in the cases where maybe there aren't coins anymore, that people are still incentivized to mine, create blocks. And I'll talk about that in a second. So, the example, this is not a theoretical example. The real example that's going to happen in, 15, 20, 30 years, is when Bitcoin gets to its 21 million coin mark. So everyone knows there's only a certain number of Bitcoins that are ever going to be created. When we get to 21 million Bitcoins, then we can't reward miners for creating blocks on the network anymore. So why are they going to be doing it? Well, they're still going to continue doing it because they get paid the transaction fees for doing it. So, if we're doing this ridiculous amount of processing to claim a transaction fee in the case of Bitcoin, because there's not new coins being created, the Bitcoin sort of proponents say that by that stage, Bitcoin will be worth so much that the transaction fees alone will be worth more than the amount of Bitcoin you'll be able to mine at that point. That the more Bitcoin we mine, the less Bitcoin will be rewarded for each block that's mined. So by that stage, you won't get much Bitcoin for doing the mining, and the currency will be worth a lot more, and you will make a lot more money by doing transactions, by serializing transactions into the blockchain as a miner. Cool. That's a lot of energy to do nothing, right? To not, like, that's just using huge amounts of power to serialize a record in a blockchain, in Bitcoin in particular. So one thing that is kind of, I think is interesting about this though, is the kind of gold rush of we've got to mine all the coins is going to be over, right? And what will be left is a distributed currency, a distributed ledger system that is essentially the books like the books are at a bank. And there's going to be this huge network of trustless computing where everyone is verifying the validity of this blockchain in a way that is irrefutable, as it is now, but everyone's blinded by the amount of gold that they can dig out of this mine. But to me, it feels kind of like it's a sign of maturity, right? That people will be using this system because it is like a bank. So this whole doing lots of processing thing is called proof of work, right? Anyone not familiar with the terms proof of work, proof of stake? Cool. So, proof of work is you sit there mining. The likelihood of you being rewarded a block, the next block in the chain, being able to create the next block in the chain, is based on how much work you can do as a miner. Now, no one is mining Bitcoin by connecting directly and mining Bitcoin directly. They're doing it through a pool, so they have this sort of hashing buying power of we're going to work together and try and do all the calculations together, and then we split the reward across all the people who are involved in the pool. Most of the big blockchain-based cryptocurrencies are proof of work based. So Bitcoin, Ethereum, for the time being, Dash, Coin, Litecoin, they're all proof of work based. So, as I was saying before, when coins run out, and it's going to happen for Bitcoin, and even Litecoin has a limit on how many coins are going to be issued. Transaction fees are the real thing, the real tangible thing that's actually going to make people want to participate in this network. So, proof of work is kind of easy-ish to understand, without going into the details. Proof of stake. So, there is no single answer to what proof of stake is, because there's so many different ideas about how proof of stake may end up being implemented. But the very basic version of it is, you get a vote on who gets to create the next block, and your vote counts as much as the stake that you hold in the current blockchain. So, and there's all variations on that, like maybe it's the amount of stuff that you've had in the last 4 months, or maybe it's the stuff you've had since the beginning, or maybe it's, there's a few different takes on it. And so next, Blackcoin, Peercoin, and Ethereum is looking like it's going to go that direction. Peercoin does things completely differently to Next and Blackcoin in that, I won't get into the details here, but Next and Blackcoin are very fairly random selection from within the stake, whereas Peercoin has got a lot more complicated stuff, and there's been problems with it. And but the thing is here is that proof of stake is an approach, and within that approach, there's going to be a whole spectrum of different solutions that end up solving this problem or trying to solve this problem. Now, the most illuminating read about this is actually the Ethereum FAQ on proof of stake, which I've linked the Ethereum document here, and it's long, but it's very informative. And because they talk about all of the other coins that are kind of playing in the proof of stake space and the trade-offs and all that sort of stuff. So, who's familiar with nothing at stake? Problem. 2 people. All right, cool. So, the whole idea of nothing at stake is, if you're doing proof of work, it's an expensive thing to do. If someone decides that they're going to create the next block regardless as to what the consensus is, then they would have to split their work halved for each new potential block that they want to create. So someone creates a fork in the blockchain. There's two competing kind of ideas of what is the real blockchain now. If a proof of work miner wanted to add a block onto each of those competing chains before consensus is reached, because this is all about consensus, they would have to split their work 50-50. And if you kind of know, like we know, the way Bitcoin works is that once the consensus has been reached, there is no negotiation about which block is the right block. So it doesn't even make sense that a proof of work miner would actually want to split their processing 50-50. But in the case of proof of stake, where there actually is no processing happening, or minimal processing happening, because they don't need to do this proof of work, it's just about what you own, right? You don't need to do some big long calculation it's actually just, oh, well, you own this much Bitcoin or whatever, and for the record, I don't think Bitcoin's ever going to go proof of stake. You own this much Ether, and this is the say that you get in the next block, and who gets to create the next block. So, in that case, if there were 5 different competing sort of blocks being created, and, well, it doesn't cost me anything, you know what I'm going to do? I'm just going to create a block on all of those competing lines in the blockchain, and just hedge my bets. It doesn't cost me anything to do, right? I've got nothing at stake. This if you go and read anything in, say, Bitcoin forums about proof of stake, it's never going to work, the nothing at stake problem, and all that sort of stuff. So it's a real thing that has been addressed, particularly in the Ethereum link that I've linked there as well. And some of the solutions for this are proof of burn, and Slasher and Caswell. So I'll talk about proof of burn as an example. So basically, if you are going to contribute to the next block in the blockchain, or you're going to create the next block in the blockchain, proof of burn means that you need to essentially take a bunch of your money, put it on the floor, and throw a match into it and burn it away to prove that you are credible and that you're not trying to maliciously manipulate the network. And so that cost, if you're doing, the reality is if you can hedge your bets across 5, you're not going to do that. You're going to do it across all possible variations. And if you have to burn that money for every single one of those variations, you're never going to do it. So that's just one of the incentives that's being used to stop people from trying to game the system, basically, in a proof of stake system. And CeCoin is also using proof of burn in a completely different context, and I'll talk about that soon as well. So obviously, proof of stake, a lot less energy consumption, which is really good for the whole green thing that I was talking about earlier. But not only that, but it means that we don't have to try and have these artificial, well, we may still have artificial, but these artificial gaps between blocks being created where when you have an ICO or whatever and everyone's wanting to buy a status, contribute Ether towards status, and these transactions get backed up. Well, a system that doesn't need to wait for the next block to be created, but can start creating them a lot quicker, can get through those transactions a lot quicker and at much more minimal cost. So anyone who's doing the maths on transaction fees and proof of work and proof of stake, their cogs will start ticking around this, and I'll get to that soon as well. Oh, damn it, I already mentioned it. And then there's other things like Slasher and which will probably be incorporated in Casper, which on Ethereum is essentially, racking my memory now, basically if you try and maliciously manipulate the blockchain, then your sort of wins from the blockchain can be rewritten a few blocks down the track, because people are like, hold on, you were totally doing the wrong thing there. Well, we're just going to write new blocks that negate your double spending, essentially. You spent the same money twice. So I think Ethereum is probably leading the field in this, and I say that because they are probably the biggest cryptocurrency that's actually considering this as an idea. Bitcoin's never going to happen. The next biggest one after Bitcoin is Litecoin.
Ripple.
Ripple, yeah. And what's Ripple doing? Do you know?
It's very free mining.
Yeah. So proof of stake actually is starting to sound a lot like what Bitcoin is going to be when there's no more Bitcoin to mine, right? It's just you get paid for doing transactions. And the reason that is the case is, and this isn't 100%, but a lot of the time with proof of stake, the coins are created at the start. And then everything from then on is just transactions with people being paid to do transactions. So, in a way, this proof of stake thing, or the simple version of the proof of stake thing, kind of sounds like what Bitcoin's going to be in 20, 30 years, whatever it is, which is a distributed ledger with people being paid to verify that it is real. So I didn't want to write too much here because I thought someone might come and beat me over the head with it later. But where I think this is going is quite interesting in the sense that the sooner that these cryptocurrencies can move out of the realm of essentially the perception of dodgy people just running these crazy miners to be rewarded with money and move into, you know what, this is just a distributed ledger. It's a way for us to maintain a record of transactions that have happened with a resource that is valuable. From there, I think we're going to see more and more sort of domain-specific coins pop up as well, which is kind of interesting too. And I think one area that's going to become really interesting is how we effectively move money through those different variations and what they get used for. Now, the slide that I forgot, that I'm now going to talk about, is can you make money from blockchains without actually doing mining or running a business or consulting or... Yeah. Anyway, there's a really great coin that's kind of doing the rounds at the moment called Sia Coin. Everyone heard of Sia Coin? Yeah. So Sia Coin is... It's another blockchain currency. But Sia, the technology, is actually a distributed storage system. And what makes Sia interesting is that it uses blockchain to record transactions from a storage point of view. So you can, as someone who has files that they want to be stored completely securely, redundantly, for a nominal fee. I think they say it's about 10% cheaper than going to any of the other mass distributed storage systems. You can go onto Sia Coin and say, I want to store my data. I'm willing to pay about this much. You dial in how much you want to pay, and you get to put your files out there. And it's not just your data's going to be replicated 3 times. It's like the network has thousands of nodes in it. Now, where does all that data get stored? Data get stored, I hear you ask. Well, where it gets stored is people who have spare hard drives sitting in their computers or their NAS or whatever that they make available on the Sia network, and they get paid to do it. And I don't need expensive mining hardware to do that. I can do that and just have the spare terabyte of data in my NAS making money for me while I'm not using it. And this isn't a hypothetical, this is real. You can go and do it now after this. Sure, it doesn't pay very well because it's still an emerging technology, but it's there, it's real, and it works. So the smart contracts on Sia Coin are smart contracts that track transaction of data in a distributed storage network.
Is that why they moved over from counterparty? Did they move over from counterparties, Sia Coin, to the Ethereum network?
They're running their own coin. Yeah. The smart contracts are Sia smart contracts, not Ethereum smart contracts. So,
but they moved over from counterparty.
I don't think so. Maybe I'm going to go and check that out after this. So, I didn't link it here because I didn't get time to do the slide, but I'll drop it into the Meetup group, which is the white paper. It's not really a white paper, it's a forum post because they haven't been able to put out the new white paper of how Sia Coin works. And it's really quite fascinating stuff. So yeah, I think there's an opportunity there to get involved, and that's just one example, right? To get involved in this and to do something that contributes to this. And in a way, making your storage available for SIA to use is an investment and an endorsement in the technology as a platform. And that's what this needs, is it needs people who are there because they see the value in it, not because they're frantically trying to mine Bitcoin and then sell it straight away. And I think this is where, like I was saying earlier, the fact that we're technologists and we kind of understand this stuff is where we can look at these new cryptocurrencies and platforms that are coming out and go, you know what, I understand why that is valuable. And if you understand why that is valuable as a technologist and you think that it has potential as a product, then maybe that's something that you want to invest in. I don't know. I'm going to be mining SIA coin. So I am scared to let people ask me questions. But if you have questions, feel free to ask me.
I think that SIA coin got storage as well, STORG.
Yeah, it's the same type.
And so you can generally put out like a gigabyte. You don't have to have a lot of data. What they say in the FAQs is like, if you have a good upload speed as well. So there's a couple of little facets that you need to take into consideration. You don't need to be sharing a terabyte. You can share a lot less. And as long as you've got the peers and you're actually contributing to the network, generally it does it over like a month or something like that. They'll build it up all the times that you've actually held data and then pay you back from there. So the one I think storage is using Countercoin, but they're building their platform around Ethereum now. They're trying to change. Storage is TORG. They're fairly new. They have a couple of apps and stuff like that. But it's a good one to have a read into. Some good FAQs to get started. So.
Actually, just one thing also on SIA coin was the proof of burn stuff that I was talking about earlier, which is on SIA coin, because you tell SIA coin how much, like SIA Tech, you tell them how much you're willing to pay to have your data stored, which means that it's like this marketplace of people can say, I will offer up my storage for this price. Yeah. And so where this kind of a potential vulnerability in this system is that I can then say that I have 10,000 terabytes and it costs you bugger all and you can use it straight away, and end up capturing enough of your data that when I turn all my computers off, you actually lose data because it's all been sent to this like dirt cheap, I thought it was like 1,000 people, but it was one guy pretending to be 1,000 people. And so the way proof of burn is used in SIA is that if you want to offer up your storage on the SIA network, you need to burn your money to prove that you're not one of these people that's doing this. So to be able to do that 1,000 times means you're going to chew through your money. That just isn't, like, the maths just doesn't add up. So it's interesting to see where this proof of burn idea is like, SIA coin is a proof of work cryptocurrency, but ideas from proof of stake, like proof of burn, are kind of crossing platforms as well, which is quite interesting.
So I'll send you a link that you can put on the Meetup group. But I was involved in a project 18 months ago where we looked at, you're absolutely right, it's consensus mechanisms. What are 4 things that any blockchain has to have? And you talked about proof of work, proof of stake. There's about 20 more. And we actually, went through the labs and went through all 20 of them and did a research paper on it.
Oh, awesome.
So I'll send you the link. You can put that on the Meetup group.
Yeah. Awesome. So Bob is quite well known in these circles. He's speaking much at the moment.
A little bit, yeah. A bit of consulting work.
Cool. Any other questions?
I think transaction fees for Bitcoin, for what are the equations or Bitcoin transactions, are they going to keep rising as the Bitcoins get to their capacity of mined?
You mean the amount that people are willing to pay to have their transaction stored? I think it will. Yeah, and the value of Bitcoin will go up as well. So there's going to be a multiplying effect on
that.
it.
Negate the smaller transaction with Bitcoins then, because the small transaction then probably the actual fee to do it will end up costing more than what you wanted to buy with whatever.
And that's where Litecoin, currencies like Litecoin come in, which is they want it to be, what was it, the silver, where Bitcoin's the gold, they want to be the silver. So where it takes 10 minutes to mine a Bitcoin, with Litecoin, I think it's 2.5 minutes. Litecoin, I think they're valued about $40 at the moment, so nowhere near the same price, but it lets you get the transactions through for a lower fee, and yeah. And Dash is another interesting one that has apparently instant transaction times. So yeah, it's never instant because you're always doing it through some website where it takes a few minutes to appear.
You can do it bidding classic. It's much cheaper.
Yeah.
Bidding classic.
Just a sort of a comment that all these distributed coins or distributed currencies, they're all still relying on centralized infrastructure. And so there's a really interesting technology coin that came out.
Can you clarify what you mean by centralized infrastructure?
Well, look, my background is mesh networking, wireless mesh networking, right? So this is truly decentralized. Like there can be peer-to-peer connections sort of anywhere, whereas at the moment we're sending everything through pipes essentially. You know, and you have to pay for those pipes at the end of the day. Someone has to pay for them. There's a node that might reroute things, but it's a network. But you have to follow the network. You can't go across it.
So you mean from an infrastructure point of view?
From an infrastructure point of view, yeah. And I just comment on it because I think it's interesting. And there's, from a wireless mesh point of view, mesh networking point of view, there's a new currency come out called IOTA.
Yeah.
It's ranking quite high now.
Yeah.
And they're using a different consensus algorithm called, like it's kind of like a tangle network, where you have a couple of peers verifying that local transactions that happened at that point and the peers around are trusted.
Yeah.
And in this way, there's actually no transaction fees for this, and it's supposed to power the Internet of Things. All the fees are so small that they're basically nothing.
And there's all the IOTA coins are being issued already as well.
I think so,
upfront,
yeah.
as part of the initial Kickstarter project or whatever they ran. Yeah.
And I just thought it was really interesting because there's no, like if there was no internet around and there was a hardware wallet or something that had this, you could still exchange coins and it could be verified and whatnot, whereas all of the other stuff, if the internet goes off, it could be kind of stuck.
What's really interesting about this sort of stuff is that a lot of these ideas have been researched before, but in the context of massively multiplayer online role-playing games, which is if you're in a room fighting a dragon, then as far as you're concerned, the only things you care about are the other people who are in that room, right? And that actually creates a locality within a network that it's not physical, it's physical in the game, but that the consensus that's arrived at in that room matters within that room, right? But at some point it needs to, cross that path into the rest of the system and, most likely over common infrastructure. But that the consensus process starts before that happens so that you can do things instantly without this kind of, like this global state that needs to be updated everywhere.
Schrodinger's cryptocurrency. Schrodinger's cryptocurrency.
That's a little bit reminds me of the Schrodinger's principle, yeah.
But who trusts the peer? And how does it build that trust?
Over time, with the other peers around it. So they all, if a new peer turns up, I don't know how it works if a new peer turns up in your network, but it would have to establish some sort of trust over time, and if it doesn't, there's penalty mechanisms built into that.
It works like real network in real life, right? I'm not going to do business with you until your friend says that you're okay. And
so it's like you're still relying on those pipes, though, right? Because that has to be hosted somehow.
Well, I mean, this is my
ideas.
ideas.
We can go in.
It depends, I guess, how it's implemented. If it's implemented in a drone, the drone's got a mesh network, and you take this concept taken to its extreme is there are machine to machine transactions. There are no humans involved. Like a drone might have an objective to try and make money doing its job, and it might be looking for things to move, and then a can of Coke might say, I don't know, something might say, I need to move from here to here, does anyone want to give me a job? And it'll pay a fee for that, the drone will automatically do the job, and then the transaction would happen. So
and I guess at the end of the day, all of these systems are designed to deal with network splits and, you know, split brain, and like you go and read the Ethereum like papers on this stuff, it reads more like what you would expect to read from a Hadoop project than you know, like a computational platform or anything like that. It's about how do we deal with like such a massively distributed network, and when parts of that network appear and disappear and stop talking to each other, and
We get paper trading.
yeah,
You learn how to trust that, but you change money through paper.
yeah.
Just give them a private key, and someone's got 100 Bitcoin or whatever it is, you know.
So that's it for me. I think we have the room until 9. You're welcome to hang around as long as you like. Talk about stuff. Like I said earlier, please let me know if you want to or know of groups and meetups that are happening around the place. There was a symposium that I couldn't make it to last week or the week before at Griffith. These are the things that are happening around here that people are talking about, and right now what we need is for people to be talking about this stuff outside of the context of, oh my god, I mined this much coin the other day. So these are the conversations that we want to be having here about the value that this stuff can bring, and not how it's lining our pockets because we've got spare processing power sitting around. So thank you for coming along. Sorry.
Since I wanted to say a few things, I want to congratulate you for
Oh, thanks.
organizing and the councillors for supporting him, and the speakers, wonderful. In fact, we organised the symposium you mentioned.
Yeah.
Fit, and I'm happy to share the link.
Yeah, that would be great. So there is a mailing list on the group as well, yeah, so please.
I'm happy to do that. The presentations are available there as well, and the papers as well. In fact, we are probably one of the leading research groups in Australia. Australia is leading in blockchain research. So I'm very surprised to hear the depth of knowledge people have here. I thought, look, what's going to happen? I came here to see. But it's very interesting. We are happy to support if anyone needs any help, technical help or business help. Our research group, not only technical, but legal, business as well. So if business or if somebody would like to study, we are happy to. Who is what?
Griffith, yeah.
Griffith, sorry. Okay, it's Muthu. I'm happy to read it, I think.
So it's ICT faculty, isn't it, right? Yeah, ICT faculty at Griffith, very active research group there.
So it's wonderful to hear. If anyone needs any collaboration, we are happy to do that.
Well, the reason I did this was I was just having all these conversations. I was like, well, this stuff is here on the coast. We need to bring these people together. So that's all this is. I want new speakers every time we do this. I want people to challenge us. And
we work on smart contracts, supply chain management, technical crypto. Example, Barbara is looking at platforms, different platforms comparing. Dr. Rehana, who just left, she works on trust from the sensor network to the blockchain. So we look at a wide range of areas. We are happy to discuss.
We have few ideas for the council. We have published few research proposals.
Correct.
More, which you
Send one through.
yeah, no, the Meetup group is a community. It's not for anyone to control any conversation. So please, everyone, contribute as you please. Yeah. Thank you.